we're going to do some of the notes and then we'll do some of the problems. Okay, define a variable, write an equation, solve, translate into equation. Okay. So these are the steps we're going to use for solving all of these. Really, this first one just means, well, what letter are you going to use in the equation and what does that letter stand for? Okay. Write an equation, that's what you have been doing, so really the second step is probably the most familiar, and then solving it, you've been doing that as well. And then the last part is just this. Write your answer in a sentence so it actually fully completes the problem. So if you get an answer of 5, well, 5 what? Go back to the original problem and say, well, I made $5, or I worked 5 hours, or lost 5 pounds, or it rose 5 degrees. Just we're going to state formally at the very end, well, what just happened in this problem. And then, of course, because you're doing that, you're going to see if it makes sense or not. That's the purpose, is that if you write it out in words, maybe if you say I made -$10, well, that doesn't really make sense to make -$10. Okay, you can reevaluate your answer, and maybe your answer is wrong, or maybe you need to change your wording. I lost $10. Making negative would be the same as losing money. So, all right, so let's get going. On the notes side, so Mrs. Math is on a diet to lose weight. After losing 26 pounds, Mrs. Math was 156 pounds. What was Mrs. Math's weight before her diet? So what are we trying to figure out here?
How much weight before the diet?
All right, and what are the units of weight? Pounds. Okay, so there's 2 ways we can do this. We can say our variable can be W for weight. Go ahead and write that in. So when you do your when you do your variables, they're usually a label or a unit. You can use one of those 2. Okay, and you don't have to write this part, but that's a label, meaning weight. Or you can use, in this case, P for pounds, and that's the unit. So those are your 2 options. Okay, and I do emphasize or. So we're finding they kind of mean the same thing. You get to pick which variable you want to use by problem, but it should be either, well, we're going to find the weight, okay, that's the label, or we're going to find the pounds, which is the unit of weight. Either way. So which one would you guys rather use, W or P? Which one?
W.
W? Okay, we're going to go ahead and go with this one then. Okay. Just knowing that there's many ways to do this properly, and if you do it slightly different, sometimes that's fine, as long as all the step is there. Okay, so using what we've been doing the past few weeks, write an equation. Okay. Anybody got what would be an equation here?
I have a equation.
Go for it.
I put
And make sure you're using W for our variable.
I put in 6 plus W equals 156.
6 plus
Or
W.
26.
Alright, so 26. And let's evaluate this. So 26 pounds plus weight before her diet equals 156 pounds. Do you guys agree with that? Well, does it make sense? Don't just look at it and say, well, all the numbers that are up here are in here, therefore it should be correct. Does it make sense? Does it make sense? This is the weight before the diet, right? So the weight before the diet plus 26 pounds will equal 156. Is that what this problem is saying?
Yes.
Some people are shaking their head no. Do you have a different option?
Can I explain mine?
Sure.
The weight, she lost 26 pounds from the diet. So if you add 26 pounds to the weight she had before the diet, after the diet, would equal the weight she had.
Yeah, so,
The weight's negative.
okay, and you have weight, negative weight, yeah.
Would it make a W minus 26?
All right. So let's try W minus 26.
Because they can't make 26 to positive.
That's what I did. That's what
Okay. Now, why did we come up with two different equations? And you can see already why it's so important to actually know what your variable is. What does W stand for? It's the weight, but which weight? It's before the diet or after the diet? Before. Okay, so that is important. Okay, how much she weighed before, then she lost 26 pounds, and then now she's 156 pounds. Okay. Over here, you take how much she was before and add 26 to that, and it'll equal 156, which means before she weighed less. If you add a 26, that means she's weighed less before the diet, which doesn't make sense. So, yeah. Very important to actually know what your variable stands for, not just say, well, weight, it starts with the letter W, so I'll have a W in there, and then I'm going to add subtract. Okay, gotta actually be thinking about it. Okay. I'm going to leave it at that. I'm just going to go through, you don't have to solve them for now. I just want to set them up and have them make sense. Okay, so let's go down here. Number 2. Which variable do we want to use here? Temperature rose 15 degrees to 70 degrees. What was the original temperature? Okay, so what variable should we use? What's the label here? Temperature is the label. Fahrenheit is the units. Yeah. So you write T equals temp. It's fine. Okay, if you wanted to use, let's say, well, technically I guess the units would be degrees, because it's like 70 degrees, but you can just stick with T. You'll notice that I always use lowercase letters, and so should you. Furthermore, when you do a T, lowercase, it should look like this. Okay? Do not do this. Why not? Looks like a plus sign. So you need to make sure it's a T, just put a little hook on it so it looks, well, and not ambiguous with a addition sign. Okay. Alright, so the temperature rose. Rose means to go up, get hotter. Temperature rose 15 degrees to 75 degrees. I mean to 70 degrees. What was the original temperature? So was the original temperature cooler or warmer than 70 degrees?
It was 15 degrees cooler.
Alright, so we're going to take our temperature. It's going to go up 15 degrees, and that's going to equal 70 degrees. Notice how I leave off the degree sign. That's all. So we're practicing the first 2 steps for now. You guys read this one, tell me what you think the variable should be. What does this variable stand for? Write it out. Define the variable. Write it out. Okay. Now, multiple ways of starting this. Anybody want to get us going? What are we trying to find? What is the question asking? So, what variable do we want to use? M for miles? Okay. So let's be very careful. I'm going to put M, and that's going to be miles. Okay. In parentheses, I'm going to make sure I put Samuel, because they're both walking, right? But we have to make sure when we're doing this, it's all about Samuel. You could, on the other hand, just say S equals Samuel. That way we'd know, that we're talking about him. Either way. But it's very important because they're both walking a number of miles. Well, when we're solving this, keep track of, well, who did you just find out the mileage for? Okay. Alright, so let's see here. Who can walk more miles 1 week? Francisco walked 7 more miles than Samuel. Okay, so I'm going to draw a little picture here. We got, and then Samuel, how much did he walk? More or less than Francisco? Okay, that's Samuel. Francisco walked 18 miles, right? How far is it from here to here? Okay, so how much more did Francisco walk than Samuel? According to the question. 7 more miles. Okay. So we're trying to figure out what? How much it is from here to here, right? That's how much Samuel. Okay, we decided on M. That's how much Samuel walked. And we know that these two are the same amount. So we have this length plus 7, so we got M plus 7 equals 18 total. So a picture was very useful for me to sort all this stuff out. A few things I had to figure out on my own. Samuel walked less than Francisco. Or Francisco walked 7 miles more than Samuel. Either way, that means the same thing. A lot of words. You can see this. Look how simple this is compared to all of this right here. And so sometimes you look at a word problem and you're like, oh, I don't even know how to start that. Really, look what it's saying. Oh, one person walked 7 more miles than another person. That person walked 18. That's all they're saying. So we don't have to let the bigger, longer word problems confuse you. Okay. Flip it over. Actually, you know what? Let's just take a break right there. Alright, let's continue on the back now. Alright. Dylan earns $13 an hour. If he brought home $403, how many hours did Dylan work? Okay, so how do we write this? Alright, how do we write this all out? Okay, so what are we trying to find? Hours. So our variable should be probably H for hours. And of course, I mean, there's only one person in this word problem, but you want to specify whose hours as well. Alright, write an equation. If you earn $13 an hour and you bring home $403, how can we write that as an equation? So if 1 hour, let's do, and dollars. In 1 hour, how much do you make? 13. And 2 hours, how much will we make? 26. In 3 hours, how much will we make? 39. And 4 hours, we'll make 50 what? 52. So they want to know how many hours does this have to go on until we get to 403. But without doing this whole table thing, right? We don't want to do that. So what's the pattern here? If we take this number h, what can we do to this number, this number, this number, this number, in order to get the dollar amount? Yeah, times it by 13. So if we take this number, this is the hours, right? And we multiply it by 13, it should equal the total dollar amount. So my equation will be $13 per hour equals $403. Notice how 13 times h, when you say an hour or per hour, that means you multiply. So for 1 hour you get 13, 1 times 13. For 2 hours it's 2 times 13. For 3 hours it's 3 times 13. For 4 hours it's 4 times 13. So for an unknown amount of hours, it's just the number of hours times 13, 13h. That's what gives us how much you made. Okay. Again, we'll finish this side and I'll let you guys solve them. Costco. Costco's good. Good pizza. 32 cans of Coke cost $8. What is the cost per can? Alright. So what's a good variable to use? We're talking about this right here. It's a good variable.
Which per can?
Yeah, but what letter should we use? C. Well, the units here would be dollars. So if you use any unit, you would say dollars. But here we can say is the cost, which means cost per can, right? That's what we're trying to find. So we have our cans. So we have the number of cans, which is 32. That costs $8. We want to know how much does 1. So per can means 1. 1 can. Right. That's what we're trying to find out. How much does 1 can cost? So, how much, what if we cut in half? How many cans did you get for $4? If
Half 32.
half of 32, which is 16. Okay. So, how can we get all the way to, well, how much 1 can costs?
You cut 2, and 8,
2 and 8? What do you mean?
like 2 cans equal half half of 4 is 2 and half of 16 is 8.
Okay, so now we know that 8 cans cost $2. We just need to get to 1 though. So what pattern? I'm trying to figure out a pattern. Up here we could just figure out, oh, is 1 times 13 to get 13, 2 times 13, 26. So is there a similar pattern here? How can I do this?
Oh, my goodness.
So, yeah, we'll go for it.
You want help?
Yeah, give me an equation. Let's just try it out, see if it works.
Alright, 32.
32.
And when you use divided by?
Okay, over.
Oh yeah, over 8. Or, yeah, division over 8 equals. Wait, take out the
Yeah, this is cans, this is dollars.
equal the cost per can. Let's see.
You kind of got it. So here we go. Dollars. Does this equal the cost per can? Now, cost per can would be, cost is going to be the dollars over the can. That's cost per can, when the dollars is on top and the number of cans is on the bottom. So I think you want this just to be flipped, if that's what we want at the very end. Yeah. So let's try this. Let's do cost, which is $8 over 32. That would equal, yeah, the cost per can. What does that come out to be? What does 8 over 32 reduce to? 1 over 4, which equals how much? How much is that in dollars? A quarter. That's 0.25. Now, how can we write this as an equation using our variable just to make it? I mean, we got all the steps here. We could figure it all out. But what would this be as an equation? Okay. So really, think about it like this. $8 will equal 32 cans times how much a can costs. That's what we're getting at. $8 will equal 32 cans. Which, to solve this, since we already did it, we'll go ahead and do it. You divide 32 on both sides, which is what we just did to get our answer. And we'll get 0.25 equals 0.25 equals C. So a can of Coke at Costco cost 0.25, 25 cents for a quarter.
That's a good deal. Yeah.
Not bad. The more you buy, the cheaper it is, right? All right, good. Now, before we move on, what would the rule be here? How would we go from 32 to 8, 16 to 4, 8 to 2? How can you do that? What can you do to 32 to get 8? 32 times 4 is 8?
Divided.
Divide by 4. 16 divided by 4 is 4. 8 divided by 4 is
2.
1 divided by 4 is, right? That's what we get. That's what we got right here. 1 divided by 4 is the 0.25. So using these charts helps you get an equation, and you can see the pattern and know that the pattern is just a repeated step. It's the same thing over and over and over. Okay. Alright, Supreme Pizza from Z Pizzas is cut into 6 equal pieces, sold individually. Each slice costs $2.75. What is the cost of the entire pizza? Okay. So once again, we're going to go with C. And I'm going to say it's the whole pizza. Again, if I have it written up here, you should have it as well. We got our pieces and we got our cost. How much does one slice cost?
$2.
Okay. How much would 2 slices cost? One. How many would 2 slices? 5. You guys tell me.
550.
550. And 3 slices? 8.25. Okay, and 25, right? Not 75. And we want to continue this all the way up to how many? 6. So that's what we're looking for. So what's the formula we can come up with? How do we get from 1 to 275? How can we get from 2 to 550? How can we get from 3 to 825? And then we can just do the same thing to 6 without doing everything in between.
We multiply times 2.
Times 2?
Because 2 times 275, wouldn't that be 550?
So we can just multiply each of these by the 275, and that will get us how much it costs. So here we go. Okay. We have sold, what's the cost of entire pizza? Yeah, 60 pizzas. Okay. So we have our $2.75 times our 6 slices equals the cost. So each of these is just times 275, 275. So if we just keep that going, that will give us our cost. Yeah, you can go and solve this. So you might have to go up to the side and do the 275. Of course, if you just have your calculator out, you just punch it in and it takes 2 seconds, right? So always good to have that available.
That's expensive.
What you got for 275 times 6? 1650 is the cost of a whole pizza. Now, does that more or less make sense? Okay, always check your answer, see if it actually makes sense, whether, if you got something like 165 because you moved the decimal point or whatever. So, and then Don't forget the $sign in that final answer. All right, good. Okay, almost done there. Okay, yard house. At the yard house, Robin's two friends decided to divide the bill evenly. Each person paid $16. What was the total bill? So we could say T for total bill. How many people are there?
3. 3 because Rob and
Yeah. Rob and two friends, so we have 3 people total. And they each paid $16, right? So how much would that be altogether? Yeah. So 16 times 3 would equal our total bill. Another way of saying it is that the total bill broke into 3 equal pieces would be $16 each. Notice how these mean the exact same thing. Just depends on how you look at it. But either way, we have an equation. What I don't want you to do is only do this and get an answer of 48 and say that's it, because it does say we do need to write equations. Remember, we're starting this on little easier problems that, yeah, maybe you can do it easily without an equation, but soon enough this stuff won't work anymore, so make sure you have an equation. You can either say $16 per person times 3 people, that's the total bill, or you can say the total bill divided 3 ways is $16. Either way, it's identical. And then when you solve each one, here you'd have to multiply both sides by 3, and you get the same answer. Okay. Now, what was the hardest part about this? Let's go back it up real fast. What did a lot of people say out loud that was incorrect earlier about this problem? How many people are there?
She said there was 2.
Yeah. So the hardest part about this was not the math, but was reading. If you don't read it properly, if you just say, oh, there's 2 people because the word 2 is there, yeah, it will mess you up.